In this section, we're talking about exponential equations, and an exponential equation is an equation that has the variable in the exponent position. So we're going to start with some baby ones and then work our way up a little bit. Okay, so this first one's really easy to do because 2 and 16 can be written in terms of a like base. So for example, I've got 2 to the x on this side, but if I think of it, 2 to the 4th power is 16. So the way that I would solve this equation for x is I would write these in terms of the same base. And since I have 2 to the x on the left and 2 to the 4 on the right, that means that x has to equal 4. And so we've solved that exponential equation. But sometimes you can't write them in terms of the same base. And if you can't write them in terms of the same base, that's where your logarithms come in. So what I want to do with this one is I'm going to take the natural log of both sides. That's the ln. Now you have a property in logarithms that says if you have a power, you can take that power and bring it out front. So now my equation is going to say x, let me fix that color for a minute, x times the natural log of 2 equals the natural log of 17. So to solve that out and get x by itself, I'm going to divide both sides by the natural log of 2. So x is actually going to equal the natural log of 17 over the natural log of 2. And on your final exam, you would be able to leave it like that and leave it in its natural log form. But I want to show you how this exponential equation relates to the other one. So I'm actually going to put mine in the calculator. On your Texas Instruments calculator, there's a natural log button. It's the ln button. So I'm going to press the natural log of 17 and I get 2.8332. And I'm going to divide that by the natural log of 2. And I'm going to get 4.087. Now, I know that that's a good answer because 2 to the 4th was 16. So this is just a little bit more than 4. And so since I'm looking for 17 there, I could say 2 to the 4.087, that would equal 17. And so that's how you would do that one. Now, the ones that you're more likely to see on your exam are going to be the E problems. And I don't want you to skip them. I want you to do them. I want you to think of E as E for easy. Okay, so what you're going to do with an exponential equation with an E is you're going to take the natural log of both sides. Now, you have a property that we studied earlier that said if you have an ln and an E together, they cancel one another out. It's like kryptonite. So 5x would be all that was left on the left side, and that equals the natural log of 72. Now to get this by itself, this is just times, so I'm going to divide both sides by 5, and x would equal the natural log of 72 over 5. Now on your final, you're going to leave them in natural log form. So if you're confused over what to do with the 72, you might just put that in parentheses to let you know that's a family and you can't break it apart. And that's your answer. Okay, so let's try the second one. To get rid of the E, we're going to take the natural log of both sides. And remember that ln and E cancel each other out. So that just leaves me with an x plus 4 equals the natural log of 41. But remember the natural log of 41, that's a family together. It's not just a 41. So you're not going to do anything to the 41. Keep it with its natural log. I'm just going to subtract 4 from both sides. So x would equal the natural log of 41 minus 4. Okay, so those are the exponential equations that you have. And then you have log equations. Okay, log equations are much easier to do in my opinion. So what you're going to do with the log equations is you're going to make circles. Now when you make the circles, you're going to start at your base. You're going to circle around and grab this number, which is the exponent. We learned that in our last section. And that equals x. So 2 to the 5th is 2 times 2 times 2 times 2 times 2. So that's 32 would equal x. Okay, let's try our second one. My base is 3. I'm going to circle around and grab the 2. Circle back, x minus 5. Now be careful, 3 squared is 3 times 3, so that's 9. To solve for x, I'm just going to add 5 to both sides. So 14 would equal x. Okay, so let's try the last one. You're going to start with your base, 4. Circle around and get the exponent, and that equals 3x plus 10. Now 4 squared is 4 times 4. Make sure you don't put an 8 because they'll try to trick you with that on your final. So 4 squared means 4 times 4. So that's 16 would equal 3x plus 10. I'm going to subtract 10 from both sides. So 6 would equal 3x. I'll divide both sides by 3. So 2 would equal x. And that's how it would work.